Ladies and gentlemen, welcome to this 10th event of 6G Research Visions webinar series. Today we have six captivating presentations which deal with the unexplored world of verticals. My name is Ari Poutu, and I'll be hosting this event today. First, a couple of housekeeping issues. So, first of all, here is the name of the webinar today. It's a deep dive into the 6G white papers on validation and trials for verticals towards 2030s. We have, as mentioned, six talks today. First, Susanna Pirttikangas will talk about vision of future services of mobility towards 2030s. Emery Yo will talk about vision of e-health services towards 2030s. I will be discussing the energy services, and Luciano Mendes unfortunately sends his apologies. However, I have received his slides and I will substitute him in agribusiness services towards 2030s. Frank Burkhardt is either in person or in video format available today to discuss the Industry 4.0 services towards 2030s. And after that, we look at one of the outcomes of this white paper, which are the vertical KPI assessment and validation, and discuss also the need for trials and what kind of trials. After that, we will have 30 minutes, approximately 30 minutes time for Q&A. And please, before we begin, we recommend that you use your full name in the Zoom profile. Write your short questions to the QA window at any time with your full name or anonymously, however you wish to do it. The panelists may then accept the question to be answered later on in the Q&A session. And as mentioned, the Q&A takes place at the end of the webinar. We will record this webinar, including the Q&A, and it will be later on openly available at the event website. In order to promote wide discussion in social media, we give you some hashtags that you can use. Hashtag 6G, 6G white paper, 6G vision, 6G research, sustainability, and those are the ones we use when we refer to the 6G white papers and the webinars. So that was the introductory slides, which I have now provided for you, and it's about time to go forward. And first talk will be given by Susanna Pirttikangas, and she's going to talk about the mobility services towards 2030s. Susanna, please.
Okay, so 6G white paper, it was a very interesting process to be part of. I participated mostly in the Industry 4.0 and this future services of mobility in the process. My name is Susanna Pirttikangas. I'm from the University of Oulu, Center for UP Comp. And in the development of ITS, Intelligent Transport Systems, which is certainly one of the most interesting verticals for 6G development due to the different requirements of low latency and reliability of service, the ITS systems mainly focus, of course, as in other verticals, on sustainability, on the safe and efficient and also environmentally friendly transportation. And there are certain megatrends that we discussed in this white paper, and they are urbanization and automation. There are so many different things evolving in intelligent transport and creating situation awareness for the for the citizens, we couldn't cover all the possible topics, so we concentrated on these. So it has been estimated that 1.3 million people migrate each week from rural areas to cities. And by 2040, 2/3 of the world's population will be concentrated in urban centers. And this certainly will create currently and will create more challenges in the transportation design and planning and implementation. And the other megatrend, automation, autonomous vehicles and deliveries, etc. So European Road Transport Research Advisory Council anticipate that we will reach fully automated passenger cars after 2030, and by this time the planes will be even more autonomous than today, and artificial intelligence will cover a lot of kind of possibilities to enhance the airline routing and air traffic control systems also, in addition to road transport and rail transport. So as I already mentioned, wireless communication is an essential part of intelligent transport systems, and also accurate locationing, positioning is one of the key themes that we need to develop further. The higher system capacity, higher data rates, lower latency, and quality of service are important things. So there are a couple of concepts, as we have limited time, we will go through here in this webinar. The first one is mobility as a service. So we want to enable in the mobility as a service concept, we want to enable people's citizens or movement within the city from place A to place B in a very fluent manner using different modalities of transport. And it aims to improve the capacity and speed of movement for the city residents. And also here, the AI-based algorithms will be expected to optimize city transport deliveries and solving especially the last mile problems that emerge. And one big theme in making all this possible is that we really need to know where all the resources lie. Where are all the people at the moment? Where are all the vehicles? Where are all the bicycles? Whatever transport modalities we require. And there is also a need that we need to select, to be able to select the available resources very flexibly. So here, wireless communication is an essential capacity. And then unmanned transportation, roads, aviation, maritime, rail. We don't, at the moment, we are talking a lot about the automation level of personal vehicles, but unmanned operation will be transparent everywhere. And actually, at the moment, connectivity already enables the intelligence within the moving objects, but in the future, we will expect more communication between the moving objects. We will expect more communication with the infrastructure and environmental sensors to enhance the safety of the unmanned transportation. And there is certainly going to be, and already is, a transformation period where the traditional and automated moving object will have to live in the space infrastructure. But also in the communication networks, there will be a need, or there is going to be a transformation period, so that we need to facilitate a mix of traditional communication and navigation systems with the future mobile and satellite systems. There will be several seamlessly integrated radio systems for data sensing, data collection from the sensors. There will be advanced integrated antenna for very accurate positioning. There will be for sensing and imaging and communication. So it's going to be a highly complex system. The vehicles can, for example, utilize different kinds of user interfaces that don't exist at the moment. So to kind of finish up, it is clear that for the sustainable intelligent transport, the system needs to be digitized, connected, and data-driven. One wireless solution will not fit all cases. 3D networking needs to be enabled, so the ground and airborne networks need to be integrated, terrestrial, satellites, and airborne. And already edge intelligence is a very important part of intelligent transport. We have seen that in, for example, in Japan, where there are already tens of thousands Toyota cars connected to the environment and enabling or leveraging the low latency algorithms provided by the edge servers. So in the near future, the moving objects will operate as robots, base stations, and terminals, and there will be a more flexible facilitation of wireless broadcast and support for high rate transmission. Also, one concept emerging, Internet of unmanned aerial vehicles, will develop very quickly to make airborne networks possible. We talk about UAV for everything connectivity, and of course the backbones of the intelligent transport system need to be the safety and reliability of the wireless system. We need to have globally agreed radio systems and communication formats, a lot of more different kinds of sensing capabilities. And as mentioned before, the situation awareness need to be very high in so many levels for the people operating in the transport system, but also the moving unmanned objects, but also in the network level and as a whole system level. So all these systems will be big and complex. One question that we can ask is who will build, finance, and operate the communication systems along the transportation routes? And I guess that's kind of ongoing discussion in also the CC community. So thank you. That was my 10 minutes. And unfortunately, I need to run to another event. So the questions can be answered by Ari and the team. Thank you.
Thank you, Susanna. You just put us on the move, not only on the cars, but also on the seminar. So thank you very much for the nice and interesting presentation. But as we have several presentations to go, we will go now for the next one. And it will be on future health services by Emery Jou. Emery, please, the floor is yours.
All right. Thank you for giving me this opportunity. Actually, okay, my colleague, okay, he went to China, and when he comes back, he needs to be quarantined for 2 weeks. So I decided that 2 days ago to give this talk. But anyway, so we are going to talk about the e-health service, okay, in the till the 2030, okay. Anyway, my colleague is the Professor Ye, okay. So let's see, okay, how do we look at the e-health? Actually, now everybody, even in Taiwan, there's so many, talk about the e-health, okay. So our view, okay, yeah, if we look at the e-service like a manufacturing process, yeah, the first thing, okay, must be the data must be right. And you better knows where the source come from. The source must be right, okay? And then the time and the place, and then of course the person including the patient, the doctor, and even the all other people in the hospital, or even the relatives, right? And overall, it's you need to make the right decision, okay? So that's the way we okay, look into the e-health in the future. So the point, okay, is all the e-health is not just inside the hospital, okay? Okay, the care outside the hospital is more important, okay? So we need to make it like a personalized the health service, okay? That means the patient themselves or other people can involve before you get into the hospital, okay? So the patient, okay, should proactively, okay, maintain their own health, right? And then the preventive care and the self-management of the chronic conditions, not until thing happen, right? Before the thing happen, then always there are some symptoms, right? So you should, okay, take care of that, okay? And the patient and the care professional, okay, including doctors, of course, okay, they will share the decision making. That means, okay, the patient should know what happened to them. I should tell a doctor what's going on. And even when all other the people care you, okay, in the hospital, okay, then you should communicate, okay, so we can make the right decision. All right. So first thing about the data, everybody knows that the health data is very complicated, okay? It's not just such a simple, it's complicated, it's a multimodal, and it's also distributed, okay? And then people take the health data as a privacy. Nobody wants to talk about it, okay? But then, okay, what? The thing, okay, the trend is, okay, annual growth rate is about 48%. So the data actually more and more and more. That's a good thing, okay? Suppose the more data, you have more information, right? And here we go, okay? More data, then we need, okay, no, we call the machine learning of the AI-based system, right? To analyze the data, okay? So not just instantly, okay? Big data sometimes is a bit like the batch process. You collect the data, you analyze it. But now we need, okay, call it real-time instant, okay, analysis based on, what you have, okay? So the important is what is the trend. So you know what's going to happen, okay, from the history, and then, okay, you better, okay, know what gives to you, okay. The same record may means different things under different conditions, right? So the real-time sensor fusion, okay, be able to adapt all the variations. Here comes, okay, we all know cloud now. Cloud is very important, but for e-health, the edge, okay, okay, the device, okay, near to you is even more important, because that detect, okay, what happened to you, and then we hope from there get the correct information, and then it can be okay, treat okay, instantly, right? So here about the location tracking and the resource allocation, and as usual, okay, high security and the secrecy, right? Whereas we need a robust communication, okay? Robust communication is not just fast, you got to be reliable, right? So the clinical data accumulated during the life of a person, okay, will be okay, estimated at 0.4 terabytes. And then our data reference for health, okay, will be over. Okay. So it's definitely big data. So how do we, handle data? If you handle it just instantly, it won't be, fast enough. So you need to, okay, take care of it, okay, on the way, all right? So the healthcare service, of course, should be human-centered, right? So, okay, from the current disease, okay, now more important is prevention of the health problem. By today's medical, we know if you can find a problem, there'll be some way can fix it, okay? Uh, and then we combine the clinical and the medical data for everyday life, okay? The data cannot be just stored solely on the mobile device. And it can also be moved back and forth from just the cloud, okay? If we want to do the real-time decision making, right? So over here come to the data, we summarize like this, okay? Somehow we need an open standard that can provide more scalable, interoperable, and a flexible solution to proprietary health information system. But as we said, okay, here a little bit paradox, right? People take the personal data at the privacy, right? So we need to work more on this, all right? So here now for our view, and also for our work, we are working on the AR/VR, VR health environment, because of the AR/VR is very powerful, right? And you can really directly, go with the user. For today's the VR system, okay, we know, okay,
3 minutes.
yeah, hmm? Yeah. But what the current VR system, okay, okay, we need to make it one. Make it simple. From now is wire become wireless, and not only now from wireless, you got to moving into what integrate with the 5G, the 6G, the system. Okay, so that's our direction. Okay, so for us, that's our simple flow. Okay, you have the patient or even the doctor. They wear the helmet, right? Okay, and today the helmet actually is almost become like a smart glass. Okay, so from there we collect the data, then we transmit the data, and then interactive with the person, and then we analyze it, and then but important is the one in the bottom about the performance, right? Reaction time got to be quick, right? And then the rate got to be right too, all right? So now here comes mobile edge computing and education. So all the background, is actually it depends on the edge of infrastructure, all right? So yeah, so our goal is for multi-user. It's not just a single user using the thing, okay? Multi-user means the patient, the doctor, and all other people can all together, and it will be multi-location remotely. And yeah, the data is multimodal, okay? So for the healthcare streaming, right? So that's what we have, okay? What we are doing working on by the AR VR technology. But as we know, there are more advanced technologies coming, right? Like a binocular vision display, okay? Like with the holographics. But then you need even to send more data more quickly, okay? Even okay, and then the real time the called the textile feedback, right? By the QoS requirement, right? So yeah, so the so that conclusion is by eliminating time and space barrier through remote surgery and guaranteeing healthcare workflow optimization. 6G will revolutionize the healthcare sector. That's our goal. So that's my so that's what we have. We have been trying on so many different cases. Okay, as simple as the space rotation, come to the cognitive function, and come to the exposure with the therapy. That's for the drug. Okay, and then we also try on the very popular Alzheimer's disease, the stroke rehabilitation. Okay, so that's what we sort of have done. Okay, actually more than this, we just show okay, a little bit of this, and finally, okay, this the project going on again to the second year. That's what we are doing. Okay, yeah, and so there are many other professors involved too. Okay, so basically coming from smart access to edge computing and the learning. Okay, and then get into the VR streaming. Okay, all right. So yeah, so thank you. Okay, I'm from Taiwan. Okay, the war is okay. Taiwan can help. Yeah. Okay.
Yeah.
All right. All right.
Excellent, excellent. Thank you for your very, very insightful talk. And however, as we have a strict timeline, we will go now to the next presentation, and this time it's going to be me. So bear with me. I'm going to say a few words about energy services for the 2030s. So I'm going to talk about what the energy sector looks like in the future. And one of the key notes when we talk about energy is that we are going to be electrified in the future. And most of the energy provided for any customer is going to be electricity in the future. So we are going towards a more sustainable world where fossil fuels used for energy are the key. The wireless connectivity is obviously the key ingredient. And one of the key opportunities here is that the energy system basically is a big entity of machines. And the 5G and 6G connectivity is especially targeted for connected objects. And as an energy, and especially electricity, is a network of connected machines. It means that this is exactly the right time to take a look at how the energy services can be made more efficient in the future. As discussed, we have these white papers coming out. I'm not going to dwell on this slide just to save some time, but going into this next one, this is collaboration with the 6G flagship and a BCDC energy project in Finland, where we looked at what type of ICT opportunities will appear in the future. And now if we take a look at that sustainability is the key driver also in the energy and electricity sector, what we start to see, and we already see in some countries, for instance in Finland, that the microgeneration is entering the distribution grid of electricity. This means that somehow we need to organize a new type of energy market, and this means a local and distributed energy market within the distribution grid is something that we need to actually acquire. Storage for fluctuations in, for instance, between day and night or winter and summer is something that we need, and power to X technologies, for instance, putting electricity into hydrogen. These are something that we are actually requiring in this change. Demand response means that you can actually, given a certain offering of energy in the network, you can basically adjust the demand. So this is basically load control. Obviously, you need accurate local production estimates so you can match the weather, the local weather to any microgeneration plant and get an accurate production estimate. And as the same applies for the consumption models. And these need to be local so that you can actually do local balancing of the grid, given that all this information is available. Aggregation of the small scale players into the market will also be necessary. So we need to have some kind of an aggregators which allow this microgeneration to enter the actual marketplace, which currently is dominated by big players. Now, if these kind of conditions can be met, and there's a lot of research is ongoing in all of these domains, what will happen is that we will have local distributed energy trading mechanisms. We can have local grid control algorithms. We have the flexibility tool to take care of the microgeneration, the storage, and the demand response. And that then eventually brings us the distributed connectivity and computation solution. And what the future smart grid, or let's put it this way, a small part of the grid, what we call a microgrid, would look like is something like this. So each home would have a home energy management system as well as these different metering equipments. And all of these are connected to a network. And these network entities are having bit aggregates, bit resolutions, having this kind of, for instance, agent-based and game theory-based trading, microgrid trading rules ongoing, selling and buying energy in the locality. And all of these, the network also have then, grid itself has voltage and frequency measurement devices. And all this information can then be used locally, for instance, for local virtualized flexibility service, meaning that between the medium voltage, low voltage substation, which is giving us this microgrid separation, you can do the flexibility within that in the future. You can have virtualized control services, meaning that you can control the voltage, the frequency, the congestion of the network, given that you have fluctuations in the production. And of course, this makes our system more resilient, since you can have local blackout compensation and islanding services. So if the grid, the big grid, which is beyond this medium voltage and low voltage substation, goes black, so basically there's a blackout, we can still operate within these microgrids, our network. And then there are non-real-time services available, which can be then do and in cloud-based environment. And all of these can actually be integrated into the mobile networks of the future. So the mobile edge computing servers could contain these kind of virtualized service functions, and then larger core, whether it's 5G core, 6G core, whatever core, could have services also providing these non-real-time capabilities for energy network or electricity network connectivity, and so on and so forth. So what type of KPIs this need, we will then discuss those in the last presentation in this session. And I will now stop sharing this presentation and go for the next one. I just received information that one of our presenters, talkers cannot join. He has something urgent which denied his coming in today. And this is a presentation by Luciano Mendes from Brazil, from Inatel, and I will go through the slides for him. So Luciano lives in Brazil, which is a country with the big cities and huge and vast remote areas, whether they are part of the Amazon or are part of the agribusiness. So that is something that Brazilians are heavily looking at. How do you provide wireless services for remote areas such as agribusiness? Let me see if I can fit this here. Good. So the motivations. The food demand in the world is constantly growing, not just because humans are increasing, the number of humans are increasing, but also because the number of animals is increasing. So a huge demand for food is always there. Now the environment is always under pressure. So this also is a sort of like a driving motivation for remote area connectivities. And what is expected from our agriculture is a higher productivity per square kilometer. And what kind of technologies do you need for these kind of agribusiness systems are, for instance, things that you use to monitor the crops, the weather, the cattle. You can detect threats, control machinery, and automation and agribusiness processes. So what is communications enough is the question. Yes, it gives us a lot of tools, but we also need navigation. For instance, 3D high definition mapping is something that you need in agriculture. You need to be able to identify real-time threats. What are requirements for the communication itself? High throughput, low latency, and large coverage for fully automated farms. Now, if you think about 6G mainstream going up to sub-terahertz, this large coverage is going to be an increasingly big problem, thus giving rise again to discussions on the lower frequencies, even for 6G servicing. And robots for heavy labor, collaborative robots in special. Precise agriculture so that the machines know where to put the seeds is something that agricultural communities are looking for. Now, expectations. Now, currently, we are in this blue line, so we are introducing 5G in many countries. Most countries have already the 4G LTE. And what the 4G is already providing us is some simple IoT connectivities and some limited monitoring applications. Now, in the 5G era, we start to have video-based applications and the first stage of automation, introducing drones and introducing automated harvesters. And then when you go to the 6G era, you will start to have really fully automated farms, low latency communication, AI integrated into the system, 3D navigation, and real-time services, which are required also for agriculture. The coverage is also always the issue in remote areas, and whether it actually requires then some portion of 3D networking, most likely yes. Some enabling technologies which is foreseen is this 3D network. So basically satellite aerial components, for instance, drone or low altitude platforms, network of AIs, network of sensors, the brain computer interfaces are expected, large intelligent services, holographic beamforming, and multiple rats. Different services can cope with different kind of radio access technologies. And one of the things which is suggested by Luciano is that Open RAN could be something that we would need also in this domain to make the prices go sufficiently low. There are also other benefits for this agriculture and remote area because it can be used for road coverage. It can be used for education and digital inclusion, remote healthcare, environmental monitoring, and disaster monitoring in these remote areas. So these are the slides sent to me by Luciano, and I hope I captured the essence what Luciano wanted to say today. Thank you very much, and I will now stop share, and I can see that Frank has made it. You had also a tough time schedule, but you have made it into the webinar, and Frank, you may start sharing and use your own computer for sharing your views and your slides. Thank you very much.
Okay, thank you very much, Ari. And just a second until I manage to share. That's always a little bit tricky. So first of all, welcome. So my name is Frank Burkhardt, and today I will talk to you and relieve Ari a little bit of much of his talking about the vision of Industry 4.0 services towards the 2030s. And I will definitely concentrate here on wireless services, as this is basically the topic that we are sharing here. So if we want to look at the 2030s, of course, we have first to look at the past and see why actually, well, industry wanted to have wireless at all. And if we have a look there, definitely it is first, they just want to get rid of the wires. Wires are, as we all know, prone to tear and wear. And well, you need to have a lot of maintenance there, their weight. So, well, let's get rid of it. And if you get rid of the cables, then we also can be able to get mobile. So the AGV, the automated guided vehicles, they become possible then. And finally, of course, it is industry is always quite long lasting. And that means if you have some machinery, well, you will not take them out just a few years, but well, you want to use them for a very long time. So if it's possible, then let's make brownfield deployment easier. And with wireless, definitely it is easier because you just have to add the function and not have to add further cables in something that is already crowded. But well, so that was the start. And meanwhile, we have progressed definitely. And there are other things now that we have imagined and which, well, we're quite comfortable with at the moment. So definitely straightforward. It is if you take machine control, so that we have a remote where we really can just control a machine, a robot, something in a reliable way. But apart from that, let's have a look here on the right side of the slide. There you see a drill head. The drill head is rotating with 12,000 rotations per minute. And just inside the tip of that drill head, there's an actuator. And one application is to control that, that actuator and also to receive the status there. Another idea or another application that is at the moment state of the art is the in-process control. So that means in the end, here we have the example of a press. The press is used, it has its pressing attempt, and then you receive the status information like here from that sliding blocks that are inside, and you get the distribution of the pressure. And on the other hand, you have a video system that also provides information about the quality of the pressing. And both combined, you're able to adapt the process just in between two pressing attempts to really keep the quality of the pressing constant over a very long time. So coming from these very specific use cases or applications, let's take a broader view. So the German VDMA, they made a survey and had a look, what are the further applications that are outside there? And here we have that examples for the machine and plant engineering. And if you have, let's say, a broader look at all that, then you see it's mostly the green parts. It is slow status information transmission, which has no real timing requirements. Then a lot of those orange cases, which are not yet fully fulfilled in 5G, they are time critical use cases. And then also we have the positioning, which is also something that industry really wants to have to be really able to grasp the next future use cases. And obviously, as I said, future use cases. Then on the right side, you have that new applications. These are the use cases, the future services now arising, or that we can see on the horizon. And here I brought in the end 3 of these use cases and want to start with the first one, which is called fluid production. So fluid production basically means you do not have an assembly line anymore. So everything basically in the factory is moving. So you have the product and all the material, the tools, also the workforce, everything is revolving around it. So you could imagine, why should we do this actually? So why is this a promising use case? And the idea behind is, if you have that type of production, first you can optimize that production for each product itself. So each product is unique in that process and it's optimum. And that also means that the vision of the industry to really produce for a lot size of 1 is really built into that process. And additionally, if we're considering the current situation with Corona, well, it would be a real blessing if you could just reconfigure a factory from one product to the other. And at the moment you see, well, one of the supply chains breaks down, you cannot produce anymore, just switch over and you can produce further. And if your old supply chain comes back, well, then you can just switch back. The next use case is what I call teleport. So it sounds a little bit like magic. That's why I really like the term, but actually it is not. So teleport basically is a fully immersive maintenance system. So that means you really have the look and feel like you were there. So just imagine you have to fix something which is broken, let's say on the moon. And obviously you will not go there and just fix it, because normally you're here on the Earth. So what do we need? First, we need to see. So that means we have to transmit a video. That's not so complicated. Then we have to handle something. So we need some, I would call it a proxy that is there at the place we want to handle things. And for us, it must look and feel like we would do it ourselves. And what I already in between the lines told is the third part, the feel of the look and feel. So that means if you do something remotely, you need some feedback. At the moment, it's more or less, let's say you have a video feedback and have maybe an audio feedback from someone telling you what is happening, but really to feel what you're doing, that's the next step, and which I would call it some 4D environment. And to be honest, of course, if we're talking about the moon, then we have the problem of distance, because we cannot cheat physics. So the look and feel will, of course, be a little bit complicated because it takes 2 seconds for what we do so that we get the feedback. But in the end, there are, I think, options even to cheat that distance. Because thinking about digital twins and artificial intelligence, that means if we have an idea what we are handling, then we can already take some of the information up in advance so that the reaction already is taking place even before the information comes back. So this, of course, has its tricks, but I'm thinking this is where we want to go, or where we will go. But if we stay on Earth, obviously that delay, at least if we stick to some 100 kilometers of distance, is not the issue. So the final service I want to show is what I call true collaboration. So at the moment, if we talk about collaborative robots, then it's more or less human doing something and a robot, let's say it's waiting. And at some point it's able to deliver something. And after that step is fulfilled, the next thing in sequence will happen. But at the moment, with the development also of artificial intelligence, we will come to the point where first, let's say with what we have in 6G, then we have the connection with more sensors. With more sensors that are attached to the robot can really see and has a better basis for estimating what is the human doing. And with that, I assume that we can really have at some point a true collaboration in the sense of the robot is doing his things, the worker is doing his things. And at some point they estimate, oh, okay, I need to support the other, and one is doing it as it's needed. And at that point, well, we will really have a co-worker who is a robot and not just a machine. Yes, so this is basically, let's say, the things about the future that I brought with me. But well, I talked a little bit or a lot about light. Where light is, there's also shadow, of course. And the question that will arise is, if these are so nice use cases, why are they not yet here, or not yet here in full? First point would be, well, 6G is not yet here. But on the other hand, there's another point that has to be mentioned, and that's the point of testing. Because we can tell industry more or less whatever we want. At the end, industry will want to have proof, because they cannot live with the numbers. They need to have something in hand so they are really sure that what we promise is really what is also happening at their facilities, so that their big questions are solved. That is it really working in my environment? Is it really working that reliable there? Okay, how did you prove it? Did you really prove it for that long time that you required to prove it? For example, if we take that packet error rate of 10 power minus 9 that we have for 6G in the industry, for ULC or mission critical use cases, if you have to wait, well, one test, for example, would take approximately 8.5 days if you just wait without any, let's say, or if you just approach it straightforward. And did we really do that? And at the end, the question is, what's the most interesting point about the industry? Who's liable if something fails? And at the end, I think industry always fears that the cost, if something fails, is with them. So coming back to the initial point here, we need to prove, or to be able to prove the industry that this, what we do, is really working under all circumstances that are there. And that then really goes into testing. And that, I think, is the topic of the next talk of Ari. And with that, I give back to him.
Yeah, thank you, Frank, for your industrious presentation. It shed a light nicely on the challenges of the nomadic factories of the future, so to say. We have one more presentation to go before the Q&A, and I will briefly go through that presentation. Okay, so here we are. One of the outcomes while discussing these different verticals was to assess, at least give a first assessment trial to what type of key performance indicators these vertical use cases, whatever they are, would be given to 6G system. Obviously, this is the first try, and it is definitely not the final truth. And this requires discussion over the next few years from the vertical communities as well as the ICT communities in collaboration to come up with the real numbers for the different KPIs that, for instance, we are listing in the white paper. Now, I have here two tables, and let's take a quick look at them, and let's see what you think about it. For instance, if you think about the link data rate, in many cases, the link data rate requirement is not very big. For instance, we estimate that in the machine type communications of the 2030s, in industries, the link data rate might be lower than 1 megabit per second. But then on the other hand, in, for instance, mobility, it could be somewhere for one car, it could be 10 gigabit per second. And a flock of cars, it could be the capacity required from one base station or one connection point could be close to 1 terabit per second. So there are certain verticals which really require huge data rates, but then on the other hand, for instance, energy is not very data hungry vertical. On the other hand, in many industrial use cases, especially where you have this ultra reliable and low latency communications, or in energy substation automation and other control algorithm, may require jitter control, which gives us time-sensitive networking research questions where you wish to go below 1 microsecond jitter when a certain command needs to arrive at certain place in the network. And this gives us an interesting research questions in terms of the jitter. In most of the verticals, the link budget is comparable, is compared to what we expect that 5G will provide. And in most cases, the link budget, due to the fact that most of the 6G use cases are using higher frequencies, we need more gain in the link budget as when we go higher, we increase the transmission or the transmitter and the receiver, mostly the receiver noise, which means that the link budget needs to be increased by further gains in the transmission and reception. Latency, when you think about it, is critical in some use cases, specifically in mobility, in industrial enhanced URLC, where you wish to do, for instance, collaborative robotics. In energy, you have these active protection circuitries, which are basically in the future possible replacement for fuses. And changing a fuse is a very labor-intensive exercise. So if we want to go for active protection circuitries, we need a rather stringent latency requirements. Mobility obviously is there one question, and if we think about airplanes, it's easy to, and these 3D networks, it's easy to come up with the number like 1,200 kilometers per hour. In 5G, the target is somewhere around 500, which basically takes into account the bullet trains, but not yet the airborne components of the possible network elements. Then if we go to some other KPIs, and again, most of these values are compared against what we expect 5G to achieve. So for some of these, we couldn't really give a number, but we just estimated the relative importance or relative performance capability compared to 5G. And for instance, in machine type communications, for instance, the cost importance is high due to the fact that the number of devices is going to be very big. Same applies with the e-health. Huge amount of people and huge amount of sensors, so the cost importance is high. In cars, most likely, in trains and airplanes, the price of a wireless terminal is mostly insignificant, which then gives us a nominal cost importance. Now, thinking about the positioning accuracy, we can see that there are a couple of verticals which are looking for extreme accurate positioning, industrial applications, as well as e-health, especially when you talk about haptic surgery. For instance, you want to go below 1 centimeter accuracies. Then for instance, in energy, it's sufficient to know your location of your devices by 1 meter. That is sufficient because mostly they are in mobile, so they are there anyways. In agribusiness, the positioning accuracy less than 10 centimeters is coming from the high precision agriculture, so that you can plant your seeds where you want with a very accurate positioning. Security in all of these domains, maybe except from the industrial MTC, is very high, more than what we now are expecting to get from a 5G system. And then about the coverage, as mentioned already in the slides by Luciano Mendes, the coverage issue in agriculture is something that is really required. The coverage is more than 50 kilometers, I expected, from one base station. Public safety, similarly, close to 10 kilometers is expected. But in some cases, when you go indoors, few tens or even few hundreds of meters can suffice. Now, we also discussed a little bit in this white paper about trials and validation. But as we do not know yet which use cases or test cases are relevant, we just wanted to discuss it in more general terms and discuss the repeatability, for instance, and a definition of use cases, so that there should be some kind of UML diagrams to visualize and document the use case, commonly agreed, for instance, within a vertical sector. A service requirement should be described, which then translate to technical requirements, also in relation to business requirements. And these are then translated into application level specification and network level specification, what type of services are requested from the applications and networks, and then boiling down to the computation and even the connectivity within the network. And one of the outcomes is that each of the verticals should have some kind of a golden reference for other testing facilities. It's a reference system that sort of like acts as a certification point where you can actually then really certify that your solution or your product or application actually offers the performance required within a vertical. So I believe I will stop here, say thank you, and maybe we will then take a look what kind of questions we have received. And let's start. First, there is a question for Frank. For fluid production, the connection between different processes is by network communication. Is all of the optimization and configuration in real time, or can it be done in advance? What the role of the network may play in there to make the process more smooth and intelligent? Frank, can you maybe have some kind of a reply on this one?
Okay, I will try my very best, because it's, let's say it's a long question, and I will, as I said, do my best here. Okay, in principle, I would assume that at least some part of that fluid production can be pre-processed, because in principle the idea is, I would say, although it's fluid, it's moving, you already have an idea what will happen. So if nothing unexpected happens, then even that process actually is already there and is established, so that you, in the best case, just have to use configuration A, B, C, so that you have that list of different configurations there. So from that, I would say yes, at least part is pre-processable, and it will definitely be done in that way. So just trying to recall the rest of that question. Basically, it was about, if I remember correctly, the network.
Yeah. What are the role? What is the role of the network? What does it play? What is the role to play in there to make the process more smooth and intelligent?
Yeah. So the role of the network, I would say, is very crucial, because I assume, let's say, at that point, that you will have some central unit or entity controlling the overall process. So that will mean you need to have all that information somehow from a single entity distributed throughout to all the components working together. Of course, they are in some way, let's say, autonomous as far as it is possible, but at the end, you need one single mind behind it. And so that's why a smooth or a very efficient network is required there. We can definitely discuss what is needed to be transmitted over the network, but as we already used the type of intelligence here, or the topic, then basically the point would be that information is transported, and to be more specific, relevant information is transported. Not everything, not every movement, but really what is the new information that needs to be acquired by the different components in the overall system. And by that, we also avoid clogging the network with things that are actually already known and don't need to be transported any further. I hope I tackled the topic with that. If not, just re-ask.
I think, at least on my part, I find your answer very, very enlightful. So thank you very much. There's a question for Emery Yo. What does the AI need to learn about the VR streaming for the e-health services? There is an answer already there, but if you would like to repeat it also for the whole audience. Mary, are you still there? Good.
Yeah, the basic, I think issue is about the radio resource management. That's the called the big question. Radio resource is not just expensive. You need to organize it. And for our purpose, for example, the AR VR, right? Then yeah, since it will be multi-user, so how many of which base station you're going to use for that? Okay, the edge of the streaming. So one of our colleague, okay, actually Professor Huang, okay, he already published some papers. He has some more paper actually publishing. Actually, he joined the second summit, right? Doing the presentation, okay, by pre-recorded, okay. So there's another paper for that. So for all of this approach, okay, in a sense, is new, okay, and so not only just for the DRL, now we also need even more other approach. One of the approach, okay, I think become popular this year is called the interpretable, the AI approach. When what you are doing, doesn't matter how complicated is the technology, you should be able to expand. And that's also more important for us because, okay, when we are set up our AR VR system for multi-user, multi-modal, multi-location, we have to know why we are using this. And so we know where we get the information, okay? In the sense, okay, I reply, okay, for Professor Huang. So I will send more message so you can see it, okay, about the paper. Presented, okay, in the second, okay, 6G World Summit, okay, at Oulu. And one more thing to say, we are definitely welcome, okay, people to collaborate with us. Actually, I've been in Oulu, I think 4 times, right? I'm missing the Oulu, particularly in the winter time. Okay, yeah. Anyway, so if you have anything interesting, actually our topic is you see our last slide is very wide. So welcome to contact me. Okay, so we can work together. Okay, thank you.
Thank you. Now there is a question for me and Frank related to how critical is the coexistence between 6G based solutions and technologies available in each vertical. As an example, the low power wide area network solutions and satellite in smart agriculture or wireless HART in the industrial automation to fully exploit potential of the technologies and meet the demands of each vertical. So shall I go first and then what you could go on the industry sector?
Okay, let's do it like that.
Okay, so to my opinion, the existing technologies, whether it's low power ones or it is cellular IoT technologies, they will be important because they will be the most likely, the most cost efficient solution for many problems to come when we turn into wireless domains in many of the applications and services that we expect to see in many of the verticals. Then coming back to the smart agriculture, the problem obviously is that you can locally build, for instance, coverage, but then how do you do the backhauling, for instance? And that is a big question that might require, for instance, the satellite component to offer for locality the backhauling capabilities. So yes, I believe that 4G, 5G, and 5G technologies will be there, and they will be serving as technologies to complement whatever we come up with 6G technologies. And hopefully we can see also some kind of an integration of these LP1s and these not non-cellular technologies into the fabric, so that we can get also the benefits of those to be exploited. But that's up to the business domain and not most likely not the research, even though we have shown ways to do it, how to combine, for instance, narrowband IoT and LoRa and so on and so forth. So that's my part. What about Frank?
Yeah. I would move in the same direction. So I think that the point of coexistence is very vital to 6G. So I think, or really my opinion is, like 6G will not have one interface or one radio access network, but will have a multitude there, because I think it is very, very difficult, one might say nearly impossible, to serve all purposes just with one air interface. So this means there will be many, many different types of wireless connectivity be used, at least in the industry, and somehow they need to work together. And that's why I think that 6G there will build, let's say, a system of systems. And this brings us down to the point that they need to coexist with each other. So be it wireless HART, be it other industrial communication systems, be it even Wi-Fi. So I'd say that because at the moment Wi-Fi, for example, is used in industry, even if, in my opinion, it is not the best to be used, but well, it's there. So at the end, these things will come together somehow, or need to have to come together somehow to really build a very good system there.
Okay, great. Then there's a question from anonymous attendee. Good. Currently, the vertical trials are being performed with 5G. So what will be the main different challenges and additional aspects we need to take for making the trials for all these verticals with 6G? If I try first, and you guys can go if you would like to go for it. Obviously, there are a few things that will be disruptive technologies with 6G, which actually do not exist currently with the previous Gs or previous generations. One of them is basically sensing, and the other one is imaging, which more or less fall into the same family. But those technologies really do not exist in a fashion that they are intertwined into the system design. And this will offer a myriad of new opportunities. And this will, for instance, in industrial applications, these imaging and sensing capabilities, and topped with less than 1 centimeter location accuracy, will provide totally new use cases which cannot be done today, for instance, in collaborative robotics. So obviously there are things that can be done with 4G. There are things that can be done even more efficiently and faster with 5G. But the fruition of the technology, given the new capabilities of the 6G system, would be for those really highly dynamic and services requiring extremely accurate performance would come with 6G. So that's my answer. Frank, Emery, you want to take a hack at it?
Yeah. So my answer to it is definitely so that one challenge will be the additional performance aspects that we have in 6G. So like I mentioned earlier, if we're talking about a very, very low packet error rate, so 10⁻⁹, that's the goal that we want to have, then we somehow have to test it. So also, again, we don't have the time if we're having latencies of 100 microseconds. So this is the challenge by numbers, so that we are having different performance. But one, I think, major aspect in 6G will be, or two major aspects. One is the coexistence that we already mentioned, or was already asked about. And the other one will be AI, because the point will be AI will be massively used in 6G. And the question is, how do we test AI? So if it's just, let's say, if the AI is trained and you will not, or you will leave it then as it is, then definitely that might be one issue. But the next question will be, will you let AI train itself further on? And then the question arises, how will you really test AI that is able to learn further? And that will be quite interesting. So that's my answer here.
Thank you. That was an interesting point of view, because the software-based testing and technologies there are just about to start to develop with speed. And I believe one of the drivers of that software-based testing is exactly the reasoning you gave, having these AI-based elements and being able to do testing, which is basically something that we didn't plan ahead. Emery, you want to go and take a crack at it from a health vertical point of view, whether there are something that would be between 6G and 5G, what are the challenges and additional aspects we need to take?
Yeah, I'm preparing to answer, send it to the to everybody. Okay. Anyway, so who talk about 6G? Okay. I'm not. How to say that? Taiwan had 5G office for 4 years, and now it ended this year. Now it moved to 6G, and as you may all know, there's a big conference happening next week in Taiwan. Okay. When the conference started, a couple of papers, nobody talk about even 5G, 6G. Now it's everything called 6G. So now you come to the question about even for our staff, right? How do we, that's called test under the 6G. Somehow, maybe I shouldn't say this, like officially, one of the things, is Taiwan direction, is on the low orbit satellites, by the big companies, in Taiwan. The good thing, we all school, are very easy to work together with the industry. So, in order to if I understand the question right, so how do we find the 6G to do the test, to verify the key value, index, right? So we are trying to move in, on that, because our team, as I said, the professor, have been in now he went to China, he already has set up the thing over there. So we do have opportunity, using the China's facility, to do some the true 6G testing. So so we'll see. That's the basic what I can say. Yeah. Okay.
Yeah. We are far from 6G becoming reality, but we have more open questions than answers, I believe. And Pekka Pirinen is asking, following the discussion of the KPIs, the next thing is to look at key value indicators, the KVIs, and that try to address also the critical societal targets. Can you elaborate that issue a little from the vertical's point of view? In generic, there are already several exercises going on in the world where we state that the 17 United Nations Sustainable Development Goals should be somehow addressed what we do in verticals, but especially in 6G, since 6G is an enabler of a lot of services in different verticals. Now, the problem is that these questions, these 17 sustainable development goals, are not simple goals. For instance, zero hunger is a rather big question, and ITUT, for instance, is trying to come up with matrix that would somehow quantify the certain characteristics of a system to be developed that would most efficiently answer the requirements of that particular SDG. And for instance, in the zero hunger case, if we can come up with a 6G system that can offer precision agriculture, we would be targeting that particular. So the real values, which are the societal values, are really hard to put into numbers, but there are exercises in the ITUT as mentioned. In the 6G flagship, we are having an exercise where we are looking at the SDGs and how to evaluate them. And there are other white papers that have come out, for instance, the Network 2020 white paper, where it is suggested to the European Commission that as part of the upcoming EU projects, these sustainability targets should be somehow taken into account, and if possible, come up with some kind of quantifiable measures how to actually target these societal challenges. That's one answer. Frank, Emery, you would wish to give your view on this?
So basically, I do not have anything further to add here. I think you have a very good opinion here, which I can directly follow.
Thank you. Emery, anything on your side? If not, I think we have basically covered the questions coming from the audience. And at the same time, we are approaching the end time of the webinar. And before we go, I would like to give you some parting slides. Okay, so thank you for joining today. And before we leave you, I have a couple of things on the plate still. We have two more webinars on this research visions series coming up. And the registration is now open for the next two webinars. And the next one is on 9th of December. We have deep dive into 6G white paper on networking, which will be hosted by Tariq Taleb. And then the next one is a deep dive into in RF enabling 6G later this year, or most likely early next year. So this one, I guess you still can register, but the date will be changed later on. And keep the conversation ongoing. So we will tomorrow send an online feedback form where you can give your roses and your even not so cute feedback as well, if you want to do that. And in order to promote, if you want to share these ideas, we will use these hashtags when we refer to the 6G white papers and webinars. And if you want to share our knowledge, share the information in these webinars, please feel free to do so. The discussion will continue. Stay tuned in 6gchannel.com. And in the 6gchannel.com, you also will find the exact date of the last seminar when it is finally fixed. So this concludes today's webinar. Thank you for joining us, and that is it. Thank you on behalf of 6G Flagship, and hope you a wonderful afternoon, evening, or morning, depending on in which part of the great world you are. So thank you very much, and goodbye.
Thank you, Ari. Yeah. Hope to see you in Oulu.
You are more than welcome, and it appears that the winter is finally coming. So if you want to come for winter, as soon as the COVID is gone, you're more than welcome.
Okay.
Also, thank you very much from my side, and also hope to see you back soon in Oulu.